20 comma 38.9. So y minus 38.9 equals the slope 0.89 x minus 20. So this is 0.89 x minus 17.8 and then plus 38.9. So then y equals 0.89x plus, I think it's 21.1. Please correct me if I'm wrong at any point in time. Write the equation in slope-intercept form. We already did. That's part B. And part C, use the linear function to predict the percentage of never married American females ages 25 to 29 in 2020. Predict the percentage in 2020. Assuming the model still holds. I don't know when the model was created. We can go back and look at the graph. But it doesn't matter. This is outside of the range. I'm predicted in the future. So I don't know if the model is still true. I'm going to say assuming the model is still true. Assuming the model still holds. What do I have to do to determine the percentage of American female, 25 to 29 years of age, potentially still unmarried in the year 2020? Yes, excellent. I have to plug in x, replace x by what? Excellent. Exactly. X equals 40 years since 1980. Indeed. X is the number of years. That's why I wrote it twice for everyone to remember that. X is the number of years since 1980. So that will be y equals 0.89 multiplied by 40 years plus 21.1. And if you give me that number, that is perfect. What is the percentage? How much? Okay, I'll do it. 0.89 multiplied by 40 and plus 21.1. I got 56.7%. If the trend continues, but we don't know that for sure. Okay, ready? Questions for me? Okay, so let's talk about parallel and perpendicular lines. Let's look at a couple of examples. On page 279, problem 10, 279. We are given a line. We are told that a line is passing through -1, 3. So passing through -1, 3 and parallel to a given line whose equation is given to us. 3x minus 2y. I think it's -5. It doesn't matter. -5 equals 0. Okay, I haven't read the problem to you yet. So let's talk about this. I'm not graphing exact anything. I'm just giving you the idea. So there is a line whose equation I would like to determine. And I do know two things about it. I know that this line is passing through this point. Somewhere along the line, I have the point -1, 3. I also know that this line, whose equation I'm interested in finding, is parallel to this line, to a line whose equation is given as 3x minus 2y minus 5 equals 0. I would like to determine the equation of the green line. So what I know so far is this point. Is this point the y-intercept of the unknown line? Would you agree it's not? Okay, so then I'm thinking of y minus y1 equals the slope times x minus x1. And I have the point x1, y1, which is negative 1 and 3. But I'm missing this piece of information, without which I can't continue. So knowing that it passes to that point, I can already put it in as negative 1 comma 3. But I don't have the slope. However, I'm told that this line is parallel to this line. Is there any way I could determine the slope of the green line? It's the same as the slope of the red line. How do I determine the slope of this line? What do I have to do? Say it again.
It's the same with parallel, right?
Exactly. But how do I determine it? Once I determine the slope of this line, I'll say this must be the same. But I have to must have the same slope. But how do I determine the slope of this line? How do I do that? What do you recommend we should do to determine the slope of the given line first? No, we don't have 2 points. We don't have any point, right? Very good question. Very good question. I don't have any points for this. I only have the equation. 3x minus 2y minus 5 equals 0. That's all I have. No? It's a very important point. Let's discuss this. How do we determine the slope of a line like this? I have the line, I want to determine the slope. What if I say will you be able, if I give you this form, will you be able to identify the slope? If I say y equals negative 2/3 x plus 2, will you be able to identify the slope of this line?
Mm-hmm.
How much?
-2.
Very good. So you understand that this equation is solved for y. This equation is solved for y, as is in descending order. That's why it's not difficult to identify the slope. Same thing here. It's in descending order. It's solved for y. Not difficult to identify the slope. But this is not what I have. This is what I have. What do you think we should do to this equation so that we put it in this form so we are able to find the slope? I would have to solve for, that's it. That's the correct answer. Do we understand? Is that clear? Once I solve this equation for y and I present it like this, the coefficient in front of x must be the, that's it. Is that clear, everyone? Please say no if it's not clear. I'll repeat what I just said. Okay, let's see it in action then. So I have negative 2y equals negative 3x plus 5. This term moves and this term moves. Please remember to keep everything in descending order. If you don't keep it in descending order, you may identify a slope that is not the slope. Okay, so I'm dividing, obviously, both sides by. Yes, we divide by negative 2. So this is y, this is 3/2 x, and this is negative 5/2.
Wait, why is it -2y?
When I move a term from one, oh, it's negative 2y because it's negative 2y. It was given to us like that.
Oh, okay, sorry.
So that's okay. So 3x moves to the other side, it's negative. So then we we divide both sides by negative 2. So negative 3 divided by negative 2 is 3/2. Negative 5 divided by negative 2 is negative 5/2. And now we are able to identify the slope as what? Exactly. Okay, so then I know that this slope, the slope of this line is 3/2. Can anyone identify the slope of the green line for us? It must be the same. They're parallel. Yes. So then 3/2 indeed. So now I put everything together. I have the point and I have the slope. So I will solve for y. So I'll write it here as y minus 3 equals 3/2 x plus 1. I distribute 3/2 x plus 3/2 and plus 3. So this is y equals 3/2 x. Can anyone give us this? The addition of 3/2 plus 3. Two times 3, 6 plus 3 is 9. 9/2. What if we have, for the same problem, another scenario? Different situation. With the same problem, with -1 comma 3. But this time the line is perpendicular. Same line. 3x minus 2y minus 5 equals 0. We determined the slope of this line a few minutes ago, 3/2. What will be the slope of this line? That's why I practiced a little bit with you. So if the slope of this line is 3/2, what should the slope of this line be in the case that now they're not parallel, but they are perpendicular? Exactly. That's why, see, that tiny little exercise gave us the insight of what happens here. Yes?
So that question on page 279, number 10.
Only asked for parallel. I just changed the problem.
No, I know, but so it was asking what y equals, right?
Yes.
And then so y equal 9 over
3/2 x plus 9/2. We're asked to find the equation. Very good question, because
I should know what that means.
so we're asked to determine the equation of this line passing through this point and parallel to this line.
Okay.
So we determine the slope, we use the point slope form, and now we have the equation of the green line. This is the equation of the green line.
Okay.
Guaranteed to be parallel. Very good question. Thank you for asking. So guaranteed to be parallel to the given line and passing through -1, 3 as indicated from the very beginning. Is that clear? Okay. So now, if it is perpendicular, then I will have y minus y1 equals the slope times x minus x1, and the same point is -1, 3, but this time the slope will be -2/3. That's the only difference between parallel and perpendicular. Just the slope is different. For parallel lines, the slope is the same. For perpendicular lines, if we know the slope of this one, you already gave me the slope of the other one. It must be -2/3 because the product must equal the product of two slopes, coming from perpendicular lines has to be equal -1. So then we will simply solve this equation. So this is a totally different example, not connected to the previous one. I used the same information from the previous one, but I changed the equation. I said the equation is the same, but it's perpendicular now. So then it's y minus 3 equals -2/3 x plus 1, and then I distribute. So this is the equation of the line that is passing through the same point, but this time is perpendicular to the given line. We'll have more examples on Wednesday as well. So this time is 3 times 3 minus 2. And the last thing, and I promise to stop, this is really the last thing for the test. The average rate of change of a function, which we know what it is. So here's the function f of x, and let's say we have 2 points. Let's say I have this point, and I have this point, and I want to determine the slope of this line. So this is point 1 with x1, f of x1, and this is point 2 with x2, and what is the y-coordinate of that point? Of course, So the average rate of change between 0.1 and 2. Can anyone give us that? Yes, it's basically the definition. Perfect. Thank you. Nothing else. Same thing with the difference quotient, the same thing with the slope, everything the same. So let's look at a function. If you want to create one, we can. I would like to use 16 on page 279. F of x is x squared minus 2x. Between 1 and 2.
Oh, between.
Yes, between 1 and 2.
Thank you.
Sure. Sorry about that. Now let me ask you this. Coming back to this graph. Do you think that this, between these 2 points, this line, or this line between these 2 points, has a higher average rate of change? This one is higher than this one, or the other way around? Which one is higher? This one or this one? The green line or the blue line? Right. It's a steeper slope, higher slope. This one is a higher average rate of change. This one, I'm not saying it's not high, but it's not higher than the previous one. What about between these 2 points? Is it higher than the previous one? No. So this is the highest from these 3 examples. Highest, smaller, smaller, smaller. It's all about the steepness of the line. Okay, so we're given this function, and we want to find the average rate of change between 3 and 6. Can anyone tell us what to write? So that equals here. Think of the formula and you'll tell me what to write. What do we have in the denominator, first of all? Excellent. What can we have in the numerator? We don't have it yet, but what should we have in the numerator? F of, indeed, f of 6 minus f of, that's it. The denominator is 3, so please let's calculate f of 6 on the side, and let's calculate f of 3. F of 6 is 36 minus 12, and f of 3 is 9 minus 6. I plugged in the functions. I plugged the 6 and 3, respectively, in the given function. So what do we get? So indeed, 24, the first one, and 9 minus 6 is 3. So this is 21 over 3. So the rate of change of this function between 3 seconds and 6 seconds, or between 3 days and 6 days, or whatever, is 7. We do not have measurement unit here. But it would have been whatever the function was measured in over whatever x was measured in. It would have been a ratio.